the Regional Director at KPM Design Services Pvt. With an engineering background, Mr. Biju has around 3 decades of experience and an MBA. KPM is a consultancy services company based in Mumbai with existence for more than 15 years, dealing in MEP, sustainability structure, infrastructure and construction. It has offices in US, Dubai, Bangalore and Pune, and have completed several projects for IT offices, hotels and resorts, hospitals and malls and multiplexes, and commercial and residential across India, the Middle East and the US. Today, Mr. Biju will talk about sustainable design for large spaces, occupants' comfort. So ladies and gentlemen, let's welcome Mr. Biju.
Designing an high side of any project, our main focus always is on the high side equipment, how to optimize the high side equipment in an energy efficient way. And second most biggest energy guzzler is the outdoor air. So we try to find out ways of how to pre-cool the outdoor air so that the amount of energy consumed by the HVAC system comes down. So we have designed many projects over the years. So I have taken 2 or 3 examples on the high side design equipment. Of course, first is the water cool chillers. This is the most easily available and most easily maintainable, and clients are also most familiar with the water cool chillers. It has, because of the higher COP that it offers for the HVAC system on the high side. So second we have done major is that where we can have a better energy efficient system on the high side is to have a combined heat and power plant. Now what people usually call it as a tri-generation unit or a CHP. What it does is that takes gas as a fuel, that is MGL gas or any other gas, and it uses the DG set to generate electricity. The electricity is used to power the building. From the heat that is generated from the DG sets, the heat is used to run the VAM machines, vapor absorption chillers machine. This reduces the HVAC chiller electricity consumption by a huge amount. It's virtually negligible. We get it's very negligible energy. And third thing that the ET is used is to generate hot waters to boilers. So this is one of we have designed this type of building for 1 or 2 projects where gas was available and where the owners were actually gas companies, and they did not have any issues with the gas rates and everything. Whether even in the future if the gas rates were going up, they were going to get the gas at a much cheaper rate. So that we had used this system in one of the biggest OEMs energy company in BKC. Now the third system usually we have designed is where we have attained high energy efficiency is use of chilled water system. Now you can see a project which is it's an island which is in the middle of the sea. So the owners did not want any of the equipments to be seen from outside, because most of the time they will be coming through helicopters to this into this island. So what we had suggested to them that we can use the seawater to generate chilled water system. You can just see so if you go to around 10 meters to 15 meters, you get a constant water temperature of water which is around 5 to 6 degrees centigrade, and this is an unending source of chilled water available. You can use as much as you want. It is never going to end. So the chilled water is then pumped using a pumping system, pump into an heat exchanger where the primary circuit is the chilled water. The seawater comes into the primary circuit and is again thrown out into the. On the secondary circuit, we have got our normal chilled water system, which now and then we have got the which is used for air conditioning the premises. Now this is a very low energy consumptions thing, and the use of refrigerants of CFC, HFC, everything is avoided. Now, if we in Bombay, we all know about BKC. BKC has got the Miti River touching it, and Miti River has an outfall to the sea. If at that point of time when they were developing the BKC, if such a system was used, you could imagine how the design of the entire BKC buildings would have changed, and the power consumptions that all the BKC buildings together take will have been nearly 30 to 40% if such a system would have been thought about at that point of. So this is a system. Of course, this system comes with a very high initial capital cost, but if you see the positive sides of it, it's very much in the long term. The ROAS will be around 10 to 15 years, but it will be worth it. Next is how do we pre-cool the fresh air? Now the speakers before me have already touched this topic. Mr. Vikram Murthy and Mr. Subramaniam and Mr. Debashis, they were so if you can use as already indicated by all the speakers before, if we can use water as a refrigerant for cooling the fresh air and maybe use an energy tunnels, earth tunnels for cooling the air, this will help in bringing down the HVAC loads to a great extent. So this we are trying out in one of our projects in Middle East, where the climate is basically dry, and we are using a combination of earth tunnels and evaporative systems. Indoor air quality. Now there are two aspects to indoor air quality. One is when you pump in the outside fresh air, the filtration that you are providing, and second is the indoor air quality, the VOCs that are being generated. How do you tackle it when it is inside when your AHUs are running? So usually what we do is that we always ask our clients to do an air quality study of the site. So what it does is it helps us to arrive at the filtration system. For example, for one of our project, which was near a dump yard, the amount of sulfur which was there in the outside air was much higher than that is recommended by all the that is recommended. So what we did was, taking this input, we were able to design and gas filters, and of course MERV 15 now is a norm. So this was to ensure that there is no smell from outside coming into the premises, as well as the quality of fresh air which is being pumped into the premises is the best. And for basically, if you go with the HUs nowadays to tackle the VOCs that is being generated within the premises, we usually go in with the PHI and the UV systems that are available now. So this is how we usually go about our design. So our focus is on the sustainability part, pre-cooling of the fresh air, and of course indoor air quality. Of course there are many other aspects. Today I just thought, since it is a short session, I will just touch these three topics. Yeah, this is a very short presentation. Thank you.